All right, advanced math A, here we go. We got lesson 10.1.1, association in two-way tables, part 2. All right, so we're going to continue on from where we were doing last time. We're kind of looking at two-way tables and trying to find out if we have association between two things. All right, so we've got, according to the U.S. Census data, we've got 312.59 million people living in the U.S. in 2011. And we're looking at the number of people that are living alone according to age. So we've got several new columns here that we haven't really seen in the previous problems. So how do we deal with that? All right, first thing we're going to do is find the probability of living alone. So we're going to take our grand total. That's going to be our denominator. So our denominator is going to be 312.59. And then who's living alone? Well, we got a lot of people living alone. We've got this 1.45, this 4.16, this 3.55, this 5.57, 6.69, 4.81, 6.5. We've got all those living alone, and we would have to find the probability by adding all those together. But the nice thing about the two-way table is they give us the total over here. So there's the total of all the people living alone. We've got 32.73 million people living alone out of 312.59 million people. So if I total all that up, let's see, 32.73 divided by 312.59 comes out to 10.47, comes out to that. Let's just call that 10.5 million. All right, so 10.5 million approximately. And that's, or not, I'm talking about percents here. What am I doing? I don't know. That's 10.5%. So a total of 10.5% of the people live alone. Let's find the probability of being 65 or older. So again, my total is 312.59. And now let's look for the people who are 65 years or older. So 65 years or older, let's see, not these people. These people are 65 years or older, and so are these people. So we've got 4 groups here that are over 65. These 2 that are living alone, and these 2 that are not living alone. They're all 65 or older. So I can just take these 2 columns and add them up. 21.4 plus 17.76. So 21.4 million and 17.76 million. So 21.4 plus 17.76. I end up with 39.16. And then I'm going to divide by 312.59. Plug it into my calculator, and I get 12.5%. All right, now it says find 2 ways to find out the probability of being under 65. All right, under 65 would be all of these people. So I could add up this number, this number, this number, this number, this number. I could add up all those numbers. Those are all the people that are in 65%. So I could take 312.59 and then add all the columns below 65. That would be these 5 columns right there. That's a lot of work, though. What we could do is use a complement. So we could look at this as saying, well, there's 2 ways that we can look at it. We can say over 65 was 12.5%. So you're either going to be over 65 or under 65. There's no in between. You're going to be over 65 and over, or you're going to be below 65. And anytime that we've got probabilities like that, they always add up to 100%. So instead of adding up all these columns, what I could do instead is just say 1 minus the opposite of what we're looking for. So the opposite of what we're looking for is 65 or older. And we already found that. It's 12.5%. So it looks like we could just find out that our answer should be 87.5%. This is called a complement. The probability of something happening plus the probability of it not happening has to be 100%. It has to. You have to be either 65 or older or not 65 or older. And then that would be 100% of the people. So when you've already found a probability, like this being 65 or older, sometimes you can just do a complement to find the opposite of it. But you could have also added all those columns below 65 and divided by 312.59. All right, what's the probability of being under 35 and living alone? Under 35 and living alone. All right, under 35, that would be these two columns, and living alone. So that would just be these two. They live alone and they're under 35. So I would do 1.45 plus 4.16 over the grand total of 312.59. So this, if I add those together, I get 5.61. Yes, I do. Over 312.59. Plug it into my calculator, and I get approximately, let's see, get approximately 1.8%. Okay, next one. To find the probability of being under 35 years of age or living alone, Anna added the total number of people in the first two columns. So these are the under 35s. She added those two columns. And the number of people in the first row. So this is a row. So she added up these two columns here and all of this row. And then she found her percentage that way, because these are all the people living alone, and these are all the people that were 35 or older. She made a mistake there, or under 35, sorry. So she made a mistake here. And can you see it now that I've circled it? Can you see her mistake? I mean, it makes sense. Here's the people under 35. Here's the people living alone. Why don't we just add those two numbers together, since it's an or problem, right? Well, her mistake here is these two numbers. These two numbers just got double counted. Those two numbers are part of this total, and these two numbers are part of these totals. So they just got double counted. So it's possible to do it like she did, as long as she subtracts out the numbers that she double counted. So she double counted the people living alone and under 35. We always have to be careful of double counting when we have an or statement. So double counted under 35 and living alone. So that's the big thing you have to watch out for when you do an or statement. Are you double counting your ands? So really watch out for that. All right, is there an association between age and living alone? So are those two related to each other? Well, what we could do is we could find our percentages to see what that looks like. Let's just do a couple of them and see if it changes our probabilities here. Let's just do the first one and see what happens. Of the under 25-year-olds, what's the probability that they live alone? Well, the under 25-year-olds, 1.45 over 111.12, that comes out to, I already think I know what the answer to this is, 1.45 divided by 111.12. comes out to about 1.3%. That makes sense. If you're under 25, you're probably not going to live alone. You probably live with your parents most of the time, right? Okay, and that means how many of them aren't living alone? Well, of course, that would have to be 98.7%. Okay, so if you're under 25, 1% of you are going to live alone. Now let's look at the other side of it. Let's look at 75 years or older. Now 6.5 out of 17.6 live alone. So let's find out what that comes out to. 6.5 divided by 7 comes out to 37%. Which means, of course, that 63% live with other people. And here we can see that these numbers are not the same. If you're under 35, you are less likely to live by yourself. You're more likely, if you're 75 or older, to live by yourself. Stupid bells! So here we can see, just by looking at those two, that there is an association. You are more likely to live with other people if you're under 25, because there's a 98% there, whereas you only have a 63% if you're 75 or older. So we can see, since these numbers are not the same, there must be an association. So yes, there is an association. All right, last page. In a recent survey of college freshmen, 35% of the students checked the box next to exercise regularly, 33% next to the box eat 5 or more servings of fruit a day, and 55% did neither. Okay, so this is exercise and not exercise. And this is eat the vegetables and fruits, and this is not eat. Now this is all in percentages, so we have to come out to 100% at the end. Okay, it says 35 did exercise regularly. That's here, 35%. It says 33 eat 5 or more, so 33% here. Then it says 57% don't do either of them, so that would be right here. All right, and now we can fill in the rest of our table. So we're going to look at our numbers here, and it looks like I can find out here that there should be 67% because it has to add up to 100%. I can see here that this should be 65% because it has to add up to 100%. 55 or 57% and 65, that means this has to be 8% because it has to add up going down here. Over here it has to add up, which means we have 25%. And over here, our last one, this is going to be 10%. What's the probability that they exercise and eat 5 servings? Exercise and eat, that's 25%. You don't need to do it 25 over 100 because it's already in percentages. That's what's nice when you have these in percentages. Exercise or eats 5 servings. You could do a complement here. You could do 1 minus 57%, which ends up being 43%. Or you could add up these 3, 10%, 25%, and 8% to get that 43%. Is there an association? Let's check. 25 out of 35. All right, 25 divided by 35, 71%. I'll just put it right here, 71. That means this number here should be 29%. 8% out of 65. 8 divided by 65, 12%. Which means this number here should be 88%. All right, so is there association? Yes. It looks like up here, you're way more likely to exercise and eat vegetables and fruits versus not over here. Here we can see that we've got a big difference between those who exercise and eat versus those who eat but don't exercise. And then there's a huge difference down here between not eating and exercise and then not eating and not having fruits or vegetables. So yes, we can see that there is a relationship. It looks like you are more likely to exercise and eat fruits and vegetables than not exercise and eat fruits and vegetables. So the people that exercise are probably going to have a healthier lifestyle is what this is telling us. All right, that's all I got for you. Math hard. See you later.